Hello and how are you? Welcome to this tutorial, which is now our final tutorial on calculus, or basically what we termed as elementary calculus. And it has been a worthy journey to looking at area approximation, integration, and also differentiation. So we are wrapping up everything in this particular tutorial, which is basically not necessarily accordance to our specific objectives or the syllabus. It's something outside class, but very important in class application. That's a very good dilemma that puts you in. Something very important, but it's not in class, but shall help you in class. I am your tutor, Dr. Joseph Adeli. Before we begin and solve that particular dilemma that you are falling yourself in, let's have a quick word of prayer, asking God to be able to guide us through. Father, Lord in heaven, thank you for this session that we have had since we began calculus. As we finalize everything, Lord, I ask for guidance as I relay this information that is very useful and you have taught me all through the ages, which is very, very important in class application and also exterior applications, but most of the time is usually not taught in class. How I pray that you, being the greatest mathematician, you who taught me this, how I pray that you may also teach others who are yet to use this material for the glory and honor of your name. May your spirit abide with them and be able to work through them as they get this information, and help them also to teach others, because that is a very good way that you have taught us, even from your holy word. Father, be with us. In Jesus' name I pray. Amen. Now, what are we aiming at in this particular tutorial? Since I said that it is something very important, taught outside class, but it's good or it's vital to apply it in class work, and mainly in exterior works outside classroom environment. What do I mean, or what am I aiming at? By the end of this tutorial, you should be able to do one thing: appreciate differentiation and integration. Simple. Now I shall want to be able to you to get what is the meaning of appreciation, because if you understand what I'm aiming, you shall be able to know the direction we are to take. You should be able to determine, let me say so, you should be able to know the course or the map that we are taking from the beginning, so that you may not try fumbling about and then you end up getting lost. Now, I have my dictionary with me and the various examples about the meaning of differentiation. The first part is transitive. We find that it means to be grateful or thankful for. For example, someone may say, I appreciate your efforts. Yeah, I appreciate your efforts. Aha, why do I appreciate your efforts? The second meaning gives more flesh to that particular statement. It says to view as valuable. It means someone says you must learn to appreciate time. It means I see some value in what has been relayed, or basically it now basically means I love the way this dictionary is basically explaining things. The third definition or explanation gives it more clear: to be fully conscious of something, or basically to understand or be aware of, or basically to detect. Your instincts are just sharp. I just pray that you have this particular kind of dictionary. It's basically a dictionary in my phone entitled English, with something like a blue book. You may try getting it. It's an application that I got on my phone from the Play Store. You can get it there, but I'm not here to say that other dictionaries are bad, but I just love its way of relaying information. Examples in a statement: it says it is essential for the reader to appreciate how important this argument is. Aha, I even like it the way it's being sourced. This is a very good argument that we are relaying in this tutorial, so it's very important. And another statement says, I appreciate that what I'm asking you to do is very difficult. And I appreciate it's difficult, yes, but I'm really asking you to do me this. Aha. Or the fourth, it's intransitive, to increase in value. It's increasing in value. So there's something I value here. So that's what we have, or basically you can say in a statement, the value of his portfolio appreciated by 80% of 8 years. That's basically what appreciation is. So it means I know what differentiation and integration is, and I value their help in life, and I know clearly where they are to be applied in. I love that second definition. I can repeat it just so that we may go together. To be fully conscious of differentiation and integration, or I simply say, by the end of the tutorial, you should be able to understand differentiation and integration, or by the end of this tutorial, you should be able to be aware of differentiation and integration, or by the end of this tutorial, you should be able to detect differentiation and integration. Very key words. Be fully conscious of, understand, be aware of, or detect. 4 things. That's what you need to know about integration and differentiation. Now, why do I bring this? It's a great shame. Why do I say a shame? People learn integration and differentiation, get very good marks in those particular topics, but don't know how to apply them unless they are given questions in class. It means if I give you a problem in the real life situation, you cannot be able to solve it unless somebody interprets it for you in a way of a question as if it was in class. For example, someone comes and tells you, I require to build a house with these specific dimensions, and I need to have also at least a garden of these particular dimensions, and also include some corridors and also those kind of stuff. Now, what will you do? Will you start fumbling about with formulas like, for example, area, volume, and other things? It's good, yes, but you need to advance. That is what we find also in the book of Timothy, 2 Timothy chapter 3. Is it 2 Timothy chapter 3, verses 15? Let me just get that verse to be able to share it with you, so that you may be able to get it. Sorry for those quite some number of noises. Let me just get it for you. It's kind of disappeared from me. Yeah, 2 Timothy chapter 2, not chapter 3. Chapter 2 and verses 15 states and says, study to shew thyself approved unto God, a workman that needed not to be ashamed, rightly dividing the word of truth. Now, I'm here not to preach, but to be able to teach integration and differentiation and how to appreciate that. But I brought this because it basically tells us that we need to study. We need to widely open our minds and be able to study to show thyself a man, a workman that needed not to be ashamed. So we don't need to be ashamed that we got straight A's in learning about integration and differentiation in mathematics, and we cannot apply them in real life situations. So you'll not always have a teacher to be able to tell you, this is the question, this is the problem, this is the number of marks, solve it and then build this house. No. You being an engineer, being an architect, being a civil engineer, whichever it is, should be able to know how to be able to decode problems and solve, to be able to show how we are going to be able to solve them in working them out. And this is the aim of this particular tutorial. I've named this additional knowledge, so it's added to what you know. So the main question, we want to look at the difference between integration and differentiation. Many people usually confuse the two. Find that you have a problem, instead of integrating, you are differentiating because you don't understand why do we have integration and why do we have differentiation, or what is the main aim of those two particular subjects. So we shall begin with differentiation, then finally go to integration. Now let us look at differentiation a bit and try to unleash what was the main aim of having differentiation and where can we apply it in. So differentiation from mathematics dictionary, you find that it's the process of determining the derived function, and we have derived this very many times when you are looking at differentiation. But here comes a question. If I want to analyze something, and have not been given any function, how will you derive that function? And you have an unknown function. Or will you just fumble and get a function from nowhere and just plug it in there? For example, I can come about and say a car was moving at from Nairobi to Mombasa, and that is a very common one that I told you also previously in a tutorial that we're working on practicing differentiation. Find that a car moves from Nairobi to Mombasa, and various data that you need to note at a time. For example, after 2 hours of its departure, the car was moving at a velocity of 80 kilometers per hour, and after 3.5 hours, the car stopped somewhere to be able to fuel, and after 2.5 hours, the car was at a specific point. Okay, I'm just saying that you have been given various data. You have no function, or I mean basically mean an equation. How will you derive to be able to get acceleration or get the specific velocity at a time interval 5 minutes after its departure? That's where you need to be able to know how to apply both integration and differentiation properly. So it's not just a matter of determining derived function. You have to derive that which is right, but with an objective. And here is the objective. Differentiation is the act of distinguishing or describing a thing by giving its different or specific difference, or I simply mean the exact definition or determination. What do I mean? If I'm analyzing the car moving from Nairobi to Mombasa and I have various data, I can look, for example, at a specific time interval. Apart from just knowing that the distance from Nairobi to Mombasa is 500 kilometers, I can come about and say, in this journey, this guy took 2 hours. From these 2 hours, I can be able to get the velocity at the average velocity. But instead of average velocity only, I can get the instantaneous velocity at a time t, of which t can be any time that that guy was traveling at. So after 2 hours, this guy was traveling at this specific velocity and that velocity. Or I can even narrow further with my velocity. I can now come about and say, at this particular instance, when he was passing Tito and A, this guy had an acceleration of this particular point. It means I'm narrowing everything down into simpler values. I'm simply giving it more definition, more weight to be able to have everything at hand, so that if I'm doing an analysis, I have a compact way of telling you of what I was analyzing. Or basically, let me give you a more tangible or a more vivid explanation. If I go to geology, in geology, I believe you know it's the study of the earth. Geology, you'll find that you have a process of separation of cooling magma into various rock types. So in their case, differentiation, according to geology, is the process of separation of cooling magma into various rock types. Now, for example, we have various rock types. We have pumice, we have, for example, gypsum, we have all those types of rocks that you will find beneath the surface of the earth. The question is, why do you have different rocks coming from the same magma? It is because their rates of cooling is different. Now mark the term rate. The rates of cooling is different, meaning there's an aspect of time. So I'm narrowing down that time to a very small value that can be able to tell me why do I have different types of rocks. So I have different types of rocks because pumice cools at a different rate than gypsum, for example, or the glass rock. They cool at different rates. So to be able to know how can I be able to have this rock and this rock, I'll have this particular differentiation. So if I bring it to mathematics, or basically an analysis, differentiation shall give me finer details of a particular whole figure. So if I have the whole figure of a car moving from Nairobi to Mombasa, I can get finer details of acceleration and velocity and name them by applying differentiation. So for example, if I am looking for let me say what I was looking at a plot let me say, no, I'm kind of unable to get a very good example at the moment, but let's apply what I've labeled to explain. So I'll derive my function that I'll have developed. So we are teaching also to develop functions, and after developing a function from the data you have, you should now be able to derive and to differentiate and be able to get finer details that you are requiring in that particular statement. In a nutshell, differentiation represents the rate of change of a function. This function can be given or not given, but if you have a problem and all the data given, you can generate a function and then get your specific finer details from that act of differentiating. I believe that I've labored enough to be able to explain what we mean by differentiation and where it's applied. It's applied whereby we were looking for finer details. So you can get all that, and I believe the topic calculus has done you good to be able to know how to differentiate. What of integration? So according to the mathematics dictionary, integration is the operation of finding the integral of a function. Correct. But you need to know where do we apply integration and why do we apply integration. So that is just a good way getting the integral of a function, but why? Let us see where integration falls in our workings. Integration is the act or process of making whole or entire by combining compatible elements, that I mean, in order to incorporate them. So I'm basically combining those particular compatible elements in order to incorporate them or make a whole diagram or make a whole figure. Let's narrow it down to a very good explanation. For example, if I want to get the total distance that a car moved from Nairobi to Mombasa, and I have acceleration and velocity, I'll basically combine acceleration, I'll combine also velocity, the time taken to each of those values that I have, in getting the full dimension between Nairobi to Mombasa, assuming that you are not told that it's 500 kilometers. In that, what am I doing? You can just shout it out. It's basically I'm integrating a function, or basically bringing it closer to us. Integration is basically, for example, if I have a piece of land and I've been given various elements of the soil of the land that I want to work with, and I want to get a very large area, I'll basically start by combining each of these particular elements, small elements that I have, to give me a very large big portion. And if I combine those small lands, I'll end up making what? The area of the plot. That's integration. Another very good example, from grammar, we can borrow this. Integrate simply means fit something together. Let me read for you from my dictionary here. In the society, the integration simply means the process of fitting into a community, notably applied to visible minorities. So for example, you may have an ethnic or migration or something. So if I'm fitting each of those guys together, I'm integrating. So if I am fitting very small parameters of a particular problem that I'm having to be able to give me a particular function or give me a very larger data, I'm basically integrating. I'm fitting them together. Or if I have ice cubes, for example, I have ice cubes and I know their volume, the volume of each ice cube. Then I pick 100 ice cubes of them of known volume and then melt them and freeze them again. I'll end up making up a larger ice block from the small ice blocks that I have. Assuming that each of those small ice blocks have equal volume, it means the volume of one of them is equal to this other one. So if I sum all these particular volumes, I'll end up getting a larger volume. It means I've collected all the cubes or the total volume of each of these small ice cubes to make a large volume. If I write it in mathematics, I'll say I've integrated. And to get that, you'll apply a process known as integration. Let me read something more else here. In biology, if I apply biology, my dictionary tells me this, but I don't love this way of applying this. It's correct, yes, but they're speaking about evolution. I don't believe in evolution because it has a lot of errors and a lot of very small things that need to be explained, which cannot be explained because they don't have evidence. So I find that in evolution, the process by which the manifold is compacted into the relatively simple and permanent, that's what we term as integration. Or I can explain it much further and say supposed to alternate with differentiation as an agent in species development. So it means I'm collecting simpler and simpler things to make a complex thing. And a very good example that I'll want to apply from biology is that if I'm applying the life of a person, you'll get that the beginning of the life of a person starts when the ovum fuses with the sperm, and when they fuse, you have a single cell organism, and it continues multiplying through a process whereby there's a growth and development that is applied to that particular cell. There's multiplication of those cells until it creates a complex being called a human being, and that happens with a period of time. So that is something you need to note. There's a period of time of which I incorporate all these values together. So it means there's a range that I'm working with. So if there's a range at which you're integrating at, that is what I'll say is integration. So you may analyze the life of a person from his childhood to his teenage youth. You'll find that there's a time span that is there. There was multiplication of cells, and when those cells are multiplying, they are creating a more complex being. Increase in volume, increase in height, all that is what we term as integration. In other terms, I simply mean integration represents an accumulation or sum of elements over a range. There must be the aspect of range. That must be there. So you cannot just work firmly from integrating from nowhere, unless you are having an integration of an infinite function. That is also integration. But in your case, I'm only confining it to what you know. There must be a range. And also, to confuse you more, the range can be from negative infinity to positive infinity. So from with that infinity range, it's also a range. That firmly tells me that integration represents an accumulation of sum of elements of a range. There must be a range. So I believe that particular vivid explanation of integration and differentiation has helped you widen your scope in working with differentiation and integration, and you can be able to appreciate why do we have differentiation. I want to get finer values. Why do we have integration? I want to get the accumulation of everything from these simpler values that I have. That's what we term as the appreciation of integration and differentiation. So I believe and hope that after getting this, you can widely share up this information with other people, so that they may be also be able to learn of what we have as integration and differentiation and be able to apply that. Even other older people, you may find that they don't know, but they have gone through calculus. So you may also share it with them so that they may also be knowledgeable, as you also saw that we need to study to show ourselves a man. And something that we need to note from the Bible in the book of Matthew, let me just allow me read that for you, so that you may be encouraged to be able to share with others. From the book of Matthew chapter 10, we'll go up to verses number 8. Verse number 8 says, "This is the words of Christ that he said, heal the sick, cleanse the lepers, raise the dead, cast out devils." Now, the next important statement is very key. "Freely ye have received, freely give." I've done my part. I've freely given it to you. Freely give it to other people so that they may also learn. That was when he was sending out the 12 apostles to be able to go and minister. So, up to that point, I shall say calculus is complete. Success in your preparations. and may God bless you abundantly.